Okay, I'm going to get started. So first off, welcome everybody. I'm glad you made it in spite of the location change. I almost did not make it. And super delighted to be here. I'm Vidya Srinivasan. I am the General Manager for Amazon Redshift. And I'm going to be talking to you today about some of the trends that we see with analytics, especially in the last couple of years, as well as some of the new, exciting, drool-worthy features that we've been working on for Redshift. Hopefully you'll have the same opinion. And I am super excited today to co-present with Colleen Camuccio, a fellow woman in tech. This is the first time I'm presenting with a woman, so I'm very excited about this. She is the VP for Program Management for Dow Jones. And in this capacity, she is responsible for all the decisions that they make for building their commerce platform. So she's going to share with us the journey that they have taken to construct their world-class data platform that serves the need for both analytics as well as data needs. So with that, I'm going to hand off to Colleen and come back later. Here, Colleen.
Thank you. Thank you so much. Super excited to be presenting with a woman as well today. This is my first time presenting at reInvent, and to present with a woman is super exciting for me. So as she mentioned, I am Colleen Camuccio. I work for Dow Jones. We are a news and information business. We are famous for our brands such as the Wall Street Journal and Barron's, for our B2B offerings like Factiva, Risk and Compliance, and we also have a whole host of advertising offerings that we can offer in the market to advertise on our platform. So I am actually working in the customer data team now, and our team is responsible for taking all of that customer data from the consumer products, from the B2B products, and from our advertising platform. And we manage all the platforms and tools that take that information and make it available for campaign, for analytics, and for reporting. I'm really excited to talk today about our big project, which is creating a brand new data platform to support this. And I don't know about you guys, but there are many times where I struggle a little bit to tell people who are not in the industry what I do for a living. So one evening at dinner, I was super excited to start working on this project, and I started talking to my kids about it and tried to explain data and tried to make it sound super exciting and talked about the cloud and said, I'm going to launch this really awesome thing in the cloud. So I walk away, and a few days later, my 9-year-old daughter comes back and starts asking me about rockets. And I was completely confused and realized that she heard me say, launch in the cloud, and immediately assumed that I did something with rockets. So I was a little disheartened for a moment, and then stood back and said, my kid thinks I'm a rocket scientist. So for any of you that struggle to talk about what you do on a daily basis, I think it's okay at a party to tell your friends you're a rocket scientist. But our decision here was not rocket science. We listened to our users of our data. We heard that there was limited visibility into what they were looking for. They were missing insights. They had multiple versions of the truth, and they really couldn't get to the data that they wanted to get to. So we decided to start a program to build a brand new world-class data platform. And in that, we wanted to make sure that we kind of turned ourselves from a cost center into a revenue driving center and organize our data in a way that we can enable new and existing revenue streams, improve our customer experience through customized communications, customized experiences, reduce our operational costs by moving to the cloud, and promote more informed decision making, putting customer data at the heart of everything that we do. Now, we did a little bit of a decision-making point where we tried to figure out what technology. We landed on AWS. And as we started to create our architecture, we ramped up something called the Environmental Council. We grabbed cloud technologists from our entire organization with different specialties. We talked to people in the industry, went to a couple third parties, and brought in folks from AWS, formed this council, and did a lot of deliberating and a lot of decision-making on the types of tools that we would use in order to build our platform. When all was said and done, we were able to do some immersion days with AWS to learn about some of the technology, and we went through the well-architected framework to determine that our platform was good to go. But then it became time to say, once the platform is up and running, What are we going to put in it? How are we going to put the data in it? And what is that going to look like? So rather than kind of bum rush the platform with the most advanced stuff we were looking to do, we decided to take a very slow approach, more of a crawl, walk, run approach, where we said, just start with the basics. Get all the data in there. Do some basic visualizations, get some value out of it, then start to gather some historical data, do some trending analysis, add more data points, do some of that cluster analysis, and then eventually we'll be in a better place to get to the really cool stuff, which is predictive analytics. So in the stage phase, we started to create our data lake. And our data lake is just a repository where you can put in raw data. But for us, it needed to be more than that. It wasn't enough to just put the raw data into the platform. We needed to make it usable to our users. So our version of the data lake is cleansed, it's performance optimized, and it's keyed so that it can be used as a standalone item for folks to comb their hands through all of the data and come up with some kind of insights. So some really good examples of data that we have in our data lake today are clickstream data points that we've brought in from our consumer products, all anonymized, but all in there so that we can kind of browse around and take a look and see what our users are reading. But we got to a point where that wasn't enough, that we had so much information in there that we needed to be able to put it together and materialize it in a way that it could make more sense and it was easy to understand to our end users. So we didn't want to completely eliminate the idea of a data mart. And a data mart for us is just aggregated data with business rules applied so that somebody who was using some self-serve tools would be able to really understand the data and utilize it. A really good example of a data mart that we've recently used is what we call our demographic data mart. Throughout your journey in interacting with the Wall Street Journal, it's quite possible that we've asked you to provide us with information about the company you work for, about your job title. And it's also possible that we've asked you that information multiple times in your life cycle with us. So the point of this data mart was to take all of this information, standardize it, because your job title could be listed in a couple of different ways, and then pick the most freshest, most relevant record and put it out to there in the form of a data mart. So this is our architecture. It's a little bit of an eye chart, but what I think you guys should take away from this is that we have a few pieces of core pieces of AWS technology that represent what our architecture is. Everything starts with an EC2 instance that brings the data into the platform. Not every system that we work with is able to drop data directly into the platform. So we use our EC2 instance and wrote programs to reach out to servers, bring data in, and call different APIs from our third-party partners to bring the data in. Everything will land in an S3 bucket when all is said and done. Once it's in S3, we use EMR and Spark to transform, process, and massage the data. And once all of that is processed and done, we utilize the Glue catalog to label, organize, partition, and make sure that all the data is organized in a way that somebody can access it. And then we decided to pick Redshift as our analytics platform and expose the information to the users. But because everything lives within S3, we're utilizing the power of Spectrum to expose that information. So as we approached how we were going to work with the data and what we were going to do with it, we talked a lot about our bucket strategy, and we utilized a lot of traditional data warehousing terms, even though we were still organizing things within the cloud. So you'll see things on here like all the data comes into landing. You'll see words like staging, warehouse, data mart. Each of those is a labeled bucket within the system. We still are using EMR and Spark to process the information as it jumps from stage to stage. And within each bucket, everything is attached to the Glue catalog so that it can be labeled and organized and partitioned. So within the staging area, that is our data lake. Everything comes in, it's transformed into Parquet. We organize it, we cleanse it, we make sure all the date formats are the same and put everything in a single format so it's easy to use. We have what we call our warehouse layer, which is really the joinability between the different items in the lake to show that these objects are related to each other. And then when it comes time to create the marts, they also live in S3. So we create what that mart looks like, leave it in S3, and we decide to either expose it in Redshift as an external table, or if we decide we want to create a physical table, it's a simple copy command from one place to the other. So I mentioned earlier on that we went through and we did this exercise with the Environmental Council, and we did some really awesome immersion days with AWS where we took a look at Athena and we took a look at Redshift and Redshift Spectrum. And we had to make a good decision about what was going to be the basis of how users were going to view and access our information. And we ended up going with Redshift because in our world, we deal with a lot of customer information and a lot of sensitive data. We have a lot of PII in our platform, and we wanted to make sure that everything wasn't readily available to everybody in terms of customer information. We wanted to be able to permission who could see what. So Redshift worked for us because we could permission schema by schema, table by table, and even make decisions field by field in terms of who could get access to things like names and email addresses and all of that information. We didn't want to make that globally available. But we still decided that it made the most sense from a cost perspective, because we were dealing with all of these records of data, to keep everything in S3 and expose it as an external table. And when creating a physical table, we're really weighing the options between cost and performance, and we're really only creating physical tables when performance isn't weighing out as an external table. So we connect Redshift directly to all of our analytical tools. We have a variety of things that folks are using, and we're creating custom dashboards for all of our users. And the really awesome thing about utilizing Redshift and Redshift Spectrum is that we only have to point to one place to access data that's in our lake, as well as data that's in our Marts. So we've created a way to join all this stuff and create this BI layer and serve this information up to our users. We've done some really amazing stuff in the B2B space, where we've taken clickstream information and information about our clients and exposed it in a dashboard that shows a really cool 360 view of what a client looks like. We've worked within our consumer space and taken information about our subscriptions and our memberships. We've taken the demographic data that has been supplied to us and our clickstream data, and we've created a really awesome dashboard where you can drill into what segments of customers are reading. And even more recently, we've worked in the advertising space to take 11 different sources that do 11 different things, create one standard format, and we've plopped a dashboard on top of it, and we're be able to provide analytics in terms of how users are interacting with ads and how the ads are performing on our site. So we've done a lot of really amazing things just by accessing information. But that's not where we stop. So we do have a lot of users that are very interested in just getting to the actual tables. So because Redshift works just like a regular database, we worked out all the provisioning. We gave users just a standard username and password, and they can use any tool of their choice just as long as it has a JDBC connection to Redshift. So we have some users that are using something like SQL Workbench to query the data. It also works really, really well with some of the SaaS products that we have installed for campaigns and for some other advanced analytics. But as long as they're armed with a data dictionary and a set of guidelines on how to harness that data and how to get it out, they found that this worked out very well for them. So when a user goes to query the data, whether they're creating a dashboard or they're just creating their own custom report, we give them a set of guidelines, because there are things that Redshift does really well and things that it doesn't do so well. And we want to make sure that all of our users are harnessing the true power of what it can do. So we tell them that they can't go and do select star. This is a specific tool to do to solve specific analytic questions, and we tell them to get the best performance that they should pick the array of columns that they're looking to use, that they should use group bys instead of select distincts, just as a form of query writing. We tell them to use with clauses instead of subqueries so that they can really harness the power of in-memory querying. Amazon Redshift does an amazing job at aggregating data, so we advise everybody to use aggregate queries wherever they possibly can when going against these really, really large data sets. But if they do need to investigate a much smaller data set, we do advise that they use filters or they just limit the row count to bring it down to a reasonable amount of data that can be looked at to decide what they're going to do, and then go back and rewrite that large aggregated query against the entire data set. And then most importantly, within the data dictionary, we call out what our data partitions are so that they make sure that they use all of those in their queries all of the time. So we've gone through our staging, we've gone through trending, we've gone through clustering, and now we're ready to start embarking on some really cool stuff with predictive analytics. And with that in mind, we set out as a vision for the platform for all of our data to be what we call AI ready. The really time-consuming stuff, the really hard stuff within a lot of the advanced and predictive analytics is the data cleansing and the data prep step. And we're trying to remove as much of that work as possible out of the hands of the data scientist, have it be built into the ultimate platform, and leaving the data scientists to do the things that they do best: model building, model training, model evaluation. So our platform makes sure that everything is prepared, organized, that it's cataloged, that it's cleansed, and it's ready for to be run directly through a model. We decided to enhance our architecture just a little bit, so we put this little thing together, and you'll notice that Redshift and our data lake is at the heart of all of it, and that we've selected Amazon SageMaker as our infrastructure for doing all of the machine learning, all of our predictive analytics, and some of our artificial intelligence that we're looking to do in the future, all still supported by our S3 buckets. So each data scientist that comes to us who wants to start using this data will be provisioned with an Analyst Sandbox, as we call it. You're going to get your own S3 bucket so that you can read into the data lake and extract out the exact data that you need and create that curated data set that you're going to need to train and to evaluate your model. Everything will live in your own bucket. Nobody will have read or write permissions to anything that's within our data lake to leave it in its own state, but you'll be able to manipulate it and create whatever it is you need to perform all of your algorithms. And we really, really liked Amazon SageMaker because it took a lot of the thinking about infrastructure and Amazon technology out of the picture and left the data scientists to do the data science work. And the way that we've kind of ramped up this architecture, we're only giving them permissions to access a Jupyter Notebook instance, to access SageMaker, to be able to read the data lake. We will have somebody who is skilled and knowledged in all of the Amazon resources to ramp up their Jupyter Notebook and just let SageMaker do all of the magic behind the scenes. So when all is said and done, we now have 12 different dashboards that support our consumer businesses, our B2B businesses, and our advertising businesses. These dashboards are powered by 30 different fact and dimension tables that are an array of external tables and physical tables within Redshift. Across the whole of this warehouse, we're at about 118 terabytes of data, and the platform is used by 100+ users every day. And that's a combination of the dashboards that we've pushed out and people who are querying the database directly. Thank you so much.
Thank you, Colleen. That was very enlightening. I'll just point out a couple of things that really resonated with me when she presented this. I have a lot of customer meetings throughout the year, and I don't think there's been anybody there who says they don't want a data lake. Pretty much everybody's trying to figure out how do they set up their analytics platform, and it's a strategy that includes a data warehouse, but also a data lake as a pretty significant portion of the platform. Many things that she said, especially to do with best practices around data lakes, are key takeaways for anybody trying to do the same. Because we've had this technology available for some time now, but I feel the reason it takes customers a longer time to get to their desired platform is because the best practices for doing these haven't quite evolved as much as, say, for data warehouses, and it's just taking a lot longer to figure out through trial and error. So the bucketing policy, the decision they made to index their lake, things of that nature, I think, is worth paying attention to because they could speed up your own journeys. All right, let me get into my section. So personally, I joined AWS in 2012, and this was the portfolio. We had just announced Redshift, and this was our analytics portfolio at that time. And this was the deepest and widest portfolio for analytics among other offerings out there. And now looking back, it feels like a much simpler world. The use cases remain largely traditional, though all of this ran in the cloud. Customers were still largely doing nightly ETL. The set of people accessing these analytics tooling was still somewhat restricted. It was the trusted set of people within organizations who had access to all of this data. But none of that holds today. And I'm going to spend some time on the trends. But before that, this is where we are today. If I look at our analytics portfolio today, it's gotten quite a bit bigger. And of course, we continue to strive to have the deepest and broadest portfolio. So what that means is, for our existing services, we say, for example, EMR or Redshift. EMR went from having just a single engine to 7 engines. Redshift put out 100 features or more just in the last year. So we do a lot within each individual service based on what customers tell us. And we've had to launch a whole array of services to keep up with your requirements, things like SageMaker, things like machine learning. All of this have been in response to what customers want to do with their data. Let's now look at some of the trends, like why are we doing all this? So the first trend that I want to talk about is just the volume of data and the data platform. So conservative figures say data actually increases tenfold every 5 years. And in our own experience, this is an average customer. The other thing to keep in mind is data platforms live for about 15 years. Now, this might seem like a very long time to you, but just think about how long have you had your Teradata box in there? How long have you had your Oracle systems up and running? Data has gravity and it tends to linger in its current form. So the platforms live for a much longer time. If you multiply the two, you end up having an environment where whatever platform you choose has to support a 1000x scale factor, which is pretty high. The second trend that we see is just the number of ways to analyze this data, to do things with this data, has been exploding. We didn't have Hadoop 11 years ago. We didn't have Presto 5 years ago. And Spark is so integral, we didn't have it 4 years ago. But these are all things that have come out and very well adopted. What you know for sure is, 2 years from now, there's going to be Spark Junior coming out, and you're going to have to figure out what to do with it. Now, we are going to go figure out how to make it a service, and this thing is just going to keep growing more and more. I think the good news there is all of us have jobs, and I think we're going to be busy for a good long time as we keep innovating in this space, and it's still not settled. We're still trying to figure out how to put all of this stuff together. And the third trend, and I think the more difficult trend to get our arms around, is the behavior of people. So I say data is the new oil. It really empowers people. So this notion of pushing down this capability of analyzing your data further down the organizations is a good one, because that probably helps your customers and your business get better returns, because they can actually make informed decisions. At the same time, what this means is this walled garden approach of protecting your data with a few people is no longer applicable. You're going to have to give it to different types of people: business analysts, executives, data scientists, people with different backgrounds and skill sets, which complicates security and management of this data quite a bit. So what does one do when all of these things come together? So a couple of things to keep in mind. One, you want to go with a platform that's flexible, things that are based on open standards and open APIs, just so when the next thing comes around, you don't have to re-architect everything you have. It's a good idea to also choose something that has a lot of choice already, because the use cases, anybody I talk to says, hey, these are my use cases, but I know in January we're going to add this other use case. We are locked down for December, but January I need your help with this other thing. And that's the case for February, March, and April. Things are moving. And scale and security, I think, are table stakes. This is just going to happen, and security is just, even just to stay in business, you just need all these controls in place for doing that. So let's now jump to Redshift. So those are the trends. With Redshift itself, these are sort of the 4 things we focus on. We like the S theme here, so we pick words that had an S in the front of it. But essentially, it's like we really want queries to go very fast. And we want to handle a lot of queries per hour. So it's about throughput and speed. That's number 1. Second thing is we want Redshift to be very easy to use, super simple to manage. Preferably don't manage it at all. Third thing is it just has to scale. It has to scale ahead of your needs, and it has to scale no matter how many of these things we have to do. And the last thing is security, which I think is pretty much a first-class citizen to be in business with data. So we launched Redshift in 2013 as a full-blown GA service. And being the first to the cloud gave us the advantage of getting a lot of adoption. And we are the largest cloud data warehouse available today. These are some of the customers that use Redshift. We have more customers who use Redshift, and even more customers who use Redshift. So clearly, my product manager was highly inspired by their ophthalmologist visit. But anyway, I did not make these charts. But anyway, the point here is the following. The advantage that you get when we handle a lot of these customers is just the fact that we get to see a wide variety of workloads. These guys fall under various different verticals. They are in different geographies, different people using the systems. So if you feel like you have this weird, unique, wacky workload, the chances are there are 100 others like it, and we've probably seen it and probably had to have put in some change to even handle it. So that gives a huge benefit to you, and that also helps us build a better product because we can see what's happening. So let's talk about some of the new features. So what have we been doing in the last year? So since reInvent 2017, we've added about 220 features and enhancements. That's a big number, but not all of them are big features. Some are small, some are big. I've highlighted some of the things that I think are significant here. But every single one of them have been as a result of a customer requirement. Either it's an existing customer, it could very well be a prospective customers. We actually get a ton of feedback during POCs, or it could be somebody just posting on Twitter saying, hey, Redshift needs to have this. And we still try to go and get these things out. These are all customer driven. Now, what you don't see as part of this 220, and what you don't see as put in our what's new post or any kind of social media, is all the stuff that we have to do under the covers to make things run smoothly. One of the first lessons I learned when I joined AWS was just the fact that there's so much work to do just to stay still operationally because the service is growing at such a rapid pace. One of the examples, for example, is around restarts. So since November last year, our restart rates, this is across the fleet, went down by about 7x. And this is while the fleet was growing. So the experience of an individual customer is even better than that. And this is meaningful and took a lot of work. But this is just one example. We've done a lot with provisioning times, with the time it takes for any single restart, and a number of other things, just to keep it very operationally stable. So let's move on to speed. So to be honest, I think 2018, and my team will agree with me, we've been kind of obsessed with performance, borderline obsessed. We've looked at lots of different ways to improve the performance of the system. And these are the results based on what we saw fleet-wide. And what I mean by that is we do monitor how long it takes for queries to run, how many queries we run, things like that, across the fleet, across all our regions, and average it out and track how we are doing over time. In the last year, we see that repetitive queries have improved 17x, bulk deletes by 10x, single row inserts by 3x, and commits by 2x. So pretty impressive for moving a database in a year. So put a lot of effort in, and it's super gratifying for us to see that this is happening to real customer workloads, because there's no artificial workload in these numbers. And this was not in any means by chance occurrence. What we did was, so it turns out we know a good data warehouse. We actually take all our own fleet metrics, dump it into a Redshift cluster, and we run all kinds of analytics on it. So what we've been doing is looking at the shape of queries, how many queries people run, how long do queries wait, how much data do typically queries go unaccessed, things of that nature. And every week we look at these numbers and try to figure out what are the set of things we can do to make them go faster. And after a year of doing that, we've been able to produce the numbers that I shared with you. So here is a quote from a customer cookpad from Japan. In the last 10 months, they've seen that their data volumes have been going up, but their commit times have decreased by 500%. All right, so the other thing we did is since we've spent so much time on performance, we said, okay, how did this affect benchmark data? I showed you the fleet-wide data, but what about standard industry benchmarks? The two benchmarks you think about when you talk of data warehousing is TPCH and TPCDS. So we ran a TPCH, I think this one is the TPCH 3 terabyte benchmark on Redshift in May and in October, and saw a 3.5x improvement just in that time frame. I'm going to share more benchmark data, but I have quite mixed feelings about benchmarks, and the reason is this. So benchmarks have been around a long, long time, and I think it's really a mechanism for a world that existed before where vendors didn't have access to real customer data and real customer workloads, not the data, just the workloads. What exact queries do people run? And customers did not have the ability to just go spin up 5 different vendors to see who does better. So they had to rely on some kind of standardized representative workload, and they had to rely on these numbers to make purchase decisions. Now, in today's world, this is entirely different. We understand the types of queries you run. As a customer, you can go spin up 5 different data warehouse clusters and run your own workload to figure out what's going on. The need for benchmarks have gone down significantly. And yet, what we see, especially in the last year, is this proliferation of benchmarking data put out by our vendors, by other vendors. And so some of these just seemed off, and so we decided we had to at least have a point of view on this, because there's just so much misinformation out there. And largely, we think some of this is really directed at getting the systems to look good by just focusing on benchmarking queries. So we ran a benchmark with Redshift and 3 other vendors. And what we saw with TPCDS is Redshift had the best performance across all the vendors that we tested. On TPCH, and we picked a 3 terabyte data set in both cases, not something super small or very large to skew results, because this is really more representative. And on TPCH, we were a close second. The approach we take internally is, I'm happy to spend time on benchmarks, but if there is really a better way of doing it, if I can really go fix problems that our customers are actually seeing, that's really what we're going to focus on. We're not going to focus on this. And I've been in companies where there have been entire teams dedicated to just optimizing benchmark queries. So you just have to take it with a grain of salt. So what I showed you in the previous chart was for hardware equivalence. This is just when we picked node types and the size of nodes to keep it largely the same across all the vendors for parity. If I look at price performance, so if you add the charge, how much does it take to run the same workload for a year? Redshift does quite well. In times, it's about 8x cheaper than one of the vendors here. And again, we have used the 1-year reserved instance pricing for Redshift and the public pricing available for everybody else with whatever discounts we could find. If you use the 3-year RI version of Redshift, you get a 75% discount. 1 year has a 30% discount, 3 year has a 75% discount. Okay, so let's jump back into some fleet data. One of the requirements I've heard from customers for Redshift is we need the ability to increase the concurrency of the system. I want to add more users, and I don't want to think about it. So we said, okay, let's go take a look at what's happening. When we looked at fleet-wide data, what we found was 87% of the clusters did not have any queue wait times for the queries. When your queries are not waiting, you essentially don't have a concurrency issue because we are absorbing things at the rate at which they arrive. For the rest of the 13%, we observed that they did wait for, there was waiting, but it happened in bursts of 10 minutes. Now, if you think about it, it's kind of similar to what you might do. Like people typically come in Monday morning and there's a burst of activity where lots of folks want to understand what happened. Maybe there's a morning sales report that they use for forecasting. There's month-end processing, weekly-end processing. So typically, the need for concurrency ends up being very bursty. So using that as a key design element, we announced a feature last week, in fact, to provide a solution for the remaining 13% of customers. It's called concurrency scaling. It's particularly for supporting this sort of bursty usage and to increase the concurrency of the system. Now, the way it works is as queries come in and we see that there is any amount of queuing, what we are able to do is spin up additional clusters. Let's just call these additional clusters concurrent clusters. So, we spin up additional concurrent clusters, one or more as needed, and the concurrent clusters can now process a subset of the queries that are waiting in the main cluster. So, we just offload those queries. The concurrent cluster has exactly the same view of data as your main cluster. So, there is no discrepancy there, and the results come back to the main cluster and get back to the client. So, there is no application change to use this. All you have to do is in the workload manager turn on a checkbox to say that you wish for this to happen if there is queuing, and we will automatically take care of all this. Behind the scenes, what actually happens is within a few seconds we are able to attach another cluster and get the query done. So, one of the things we decided to do is not to wait to fully rehydrate the concurrent clusters with the data before querying. And the reason for this is twofold. The first thing is it just takes a long time. If you're thinking of short bursts of activity, you can't quite wait for your data set to fully be hydrated. There's physics involved there in moving data. The second reason is it's going to be expensive. The minute we start putting your data on a cluster, we have to start charging because nobody else can use that. And I think that is also not ideal, given that these burst clusters are going to be charged by the second of usage. It's far better to just use it for the duration of the query time itself. What we have done, however, is try to come up with clever ways to make the performance of these concurrent clusters go really fast. So, things like caching, things like pushing down predicates, things like scaling reads under the covers with many more nodes. So, we have a bunch of techniques that we have implemented to make these concurrent clusters highly performant. So, here are some of the results. The graph that you see here is the throughput, the queries per hour that you see on one cluster, and the throughput that we get today, and this is still in preview, throughput that we get as we add more concurrent clusters. And you can see that it's close to linear, not quite linear, but close to linear scaling. So, the pricing scheme for this works as follows. You pay for the number of seconds that you have or use concurrent clusters. And based on the usage patterns that we see on the fleet today, actually I should mention the other thing. The other thing is we also offer 1 hour of free usage for concurrent clusters for every 24 hours of usage of your main cluster. So, you get an hour for free. Think of an hour for free every day. Based on the usage, that essentially means 97% of customers will pay nothing even when they use this feature, just because it's bursty and it's bursty for short amounts of time and just gets spread out throughout the day. So, that's our concurrency feature. Moving on to simplicity, very excited to announce elastic resize. So, this feature essentially helps us take our resize, which could take several hours depending on how much data you have and the size of your resize, from several hours of write outage to just a few minutes. So, pretty significant if you think about wanting a system that's far more responsive to the needs. We've GA'd this a couple of weeks back now, and the core reason it's so much faster is because this resize, we basically resize by just adding and removing nodes to an existing cluster, not by moving all the data to a new cluster. We're starting to see a couple of use cases that people are using this for, and this is the feedback we've gotten. One thing is people say, hey, before I used to think about resizing up in anticipation of more data that will come in a month from now. Now I don't have to do that. I can just do it far closer to when the data actually comes. So, that saves money. The other thing is sometimes you just get a lot more data than you anticipate, and again this helps just respond to that really fast. And the third use case is I've also seen customers resize up for, let's say, a month-end ETL job that's really heavy. So, having those extra nodes deal with the ETL helps make sure that the job gets done by the 4 a.m. cutoff or whatever it is to start the reporting job. So, that's another way to use resize, and then you resize back down when the job is done. So, lots of lots of use cases there. The next feature is a query editor. So one of the requirements we got, especially I think for data scientists, is they wanted to query Redshift with zero setup. They did, there's any number of tools available for querying because Redshift is ODBC JDBC compliant. They do require that you download the tool and install it and maintain it. People don't want to do that. And so this is an editor, a SQL editor, very similar to the Athena SQL editor, if you're familiar with that. That's in the console. It's part of the AWS management console. And you can just submit your queries. It has nice highlighting. It does autocomplete and some nice features. So this was already launched. And then another feature here is a Redshift Advisor. Again, we launched this in July. And the idea here is, we were doing all these best practices blogs and books and documentation around best practices. And we said, hey, it's very hard for people to go read this, figure out how it's applicable to their environment, and go actually do something about it. So we just have to put all of that in code. And this is the result of that. So an advisor essentially captures all the best practices in code, and then it analyzes what you're doing with your cluster, with your workload, and the data, and it tells you exactly what to do to optimize your cluster. These could be things like using better compression schemes, talking about data skew, any number of things. I think we have about 10 recommendations now. 96% of our clusters have actually benefited from this feature. And it has a button that says, hey, do you want to just take action on this? We can just make this, optimize it for you automatically. So that's the Redshift Advisor. The other thing we've heard from customers is we really don't want to be responsible for picking distribution keys. As you're aware, for MPP systems, picking a good distribution key is material because co-located joins do speed up your queries quite a bit. But then picking the right one isn't always easy. So feature, what we will do is start off a table. When the tables are born, they're typically small. So we start off a table and say, hey, I'm just going to put you on all the nodes, distribute all, that way it's always there. Doesn't matter what query comes in. And then as the table size grows, we're going to move that from a dist all style to a dist even style. And then finally, we'll move it to a distribution key style, where we'll actually pick the appropriate key based on the query patterns that are coming in. So if we take if all of that is done, then really what we are left with is three things with respect to maintenance. One is analyze. This is the operation to give us table statistics, so we can be smart about query plans. There is a concurrency setting for workload manager, and then a vacuum. Vacuum allows us to compact your disk space, delete stuff, and resort. And all of these three operations are essentially getting fully automated. And they've already been out in various stages in different regions. As an example, Analyze, for example, is already GA in a couple of AWS regions. And I was just talking to my team this morning, and they said, hey, just in the last 24 hours, more than 500,000 tables were analyzed in just a very small region that we had. So pretty mind-blowing. This is more than what we had anticipated. And as a result, the shape of the query performance for that region has improved because we can do better planning. And so very excited to get this rolled out across all our regions. With the concurrency setting feature, essentially what we want to do is to ask you not to set up any queues. We'll just figure out, set up one queue. We'll figure out how to set up the concurrency and how to distribute. As you can imagine, it's quite nice to have this work along with the concurrency scaling feature, because if there exists queuing, we can offload it to other clusters. And vacuum delete is already out, where it happens automatically. We'll do the same for vacuum sort. We'll also be supporting stored procedures for Redshift, particularly to aid migration. I know this has been a pain point based on the platform that you're coming from. And of course, we are going to support PL/PG SQL because we are a Postgres-based system. So that's another thing to look forward to. Talking about scale and integration with the data lake, our primary feature in this area is Redshift Spectrum. This is something that we launched last year. And what it allows you to do is directly access data in open formats in your lake. And even join the data with the Redshift data through a single endpoint. This is what Colleen talked about as being nice for their system. So with Spectrum, we continue to expand the set of formats, sort of the surface area of Spectrum in terms of what it can go access and process. We added support for ORC, nested JSON, and things like that. And we're also investing quite heavily in making it go faster. There have been a lot of changes done within the optimizer, but also we currently have the Spectrum request accelerator. It's really a cache for Spectrum in beta, and that will also be made available, which will speed up things quite a bit more. Apart from that, we also want to make this life cycle of data as it goes through the data lake and Redshift a lot easier. So for example, we added support for loading from Parquet into Redshift itself. And we see what the customers want to do is, say, use Spark against their Parquet data, put it in Redshift, massage the data, aggregate it, and then export it back so it can be used by some other tool. And now we will be supporting unload to Parquet to facilitate this sort of data movement and just make it easier. With respect to security, we have we've had security right from day one. We really believe security has to be a first-class citizen, and you shouldn't have to pay extra for it. It should just come with the product. We've supported end-to-end encryption at rest right from day one. So all your data at rest, whether it's on disk, whether it's in the backup format in S3, or it's spilled in the middle, all of it is encrypted. So is all data in motion. To protect your actual data, we have the compute nodes of the Redshift cluster reside in different VPC than the endpoint. The SQL endpoint is the only thing that you get to have in your own VPC. This really protects your data from intruders. And of course, we have all the standard compliance things around auditing and logging all API access and things like that, and a whole bunch of certifications as a result. I think the next big thing for security is making sure that we can have a secure environment and an easily managed secure environment in the context of the data lake. If you attended Andy's keynote this morning, he just announced a new service called AWS Lake Formation. And the basic idea there is we're moving to a model where there's a whole bunch of data, and then there's a whole bunch of engines on top trying to use that data. And we believe that the security for this data access control of all of this has to be close to the data and below the engines. This way, you don't have to define this in every single engine that you wish to use. So the lake formation service will take care of defining and maintaining the security policies for your data, and Redshift will integrate with it so that we abide by the policies that have been set. And that way, you get to set your policies just once. Okay, so that's largely what I had to cover. This is just for those of you taking pictures. If you want to go back and share some key features, these are the ones I've talked through most of them. One last note on places to learn more about Redshift. So we just launched an ebook. It's actually quite nicely done. It's like a little primer on Redshift. You just go to there's a link here, but you can certainly just go to the AWS Redshift page, and there's a link that takes you back to the ebook. And there are many other things. You can sign up for our concurrency scaling beta if you wish, and lots of other resources here as well. Thank you.